Next topic has the relation between rise time and bandwidth. For that, consider an ideal low pass filter. Ideal low pass filter characteristics, that is h of omega is equal to 1 into e power minus j omega td from minus omega c less than or equal to omega less than or equal to omega c, and it is equal to 0 otherwise, where this 1 will be nothing but our magnitude response, like this, from minus omega c to plus omega c, this mod of h of omega, and this theta of omega will be called as minus omega t. That's linear phase. It's a linear phase and the magnitude will be constant from minus omega c to plus omega c. That's all frequency components will be passed from between the minus omega c to plus omega c. Therefore, from this h of omega, take the inverse Fourier transform. Take the inverse Fourier transform and calculate our h of t. That's h of t will be equal to 1 by 2 pi from minus infinity to infinity h of omega e power j omega t d omega. Substitute what is our h of omega, which is nothing but our transfer function of an ideal low pass filter. As the ideal low pass filter will only exist from minus omega c to plus omega c, therefore the limits will be from minus omega c to plus omega c, and this h of omega is 1 into e power minus j omega td and to e power j omega t d omega. Combine the two exponentials, that's 1 by 2 pi from minus infinity to infinity, minus omega c to omega c, that's e power j omega t minus td d omega. Perform the integration of this particular exponential, that is equal to 1 by 2 pi e power j omega t minus td by j into t minus td, because we are integrating with respect to omega. Therefore, j into t minus td will be the constants. Upper limit is omega c and minus omega c. Then 1 by 2 pi, when we substitute upper limit, e power j omega c t minus td minus e power minus j omega c t minus td by j into t minus td. Then it is equal to, take this to this side and the t minus td to this side. That's 1 by 2 pi t minus td to this side. Therefore, it is entire thing will be equal to, it is the e power sine of omega c of t minus td. Then multiply an omega c and divide by an omega c, sine of omega c of t minus td by omega c of t minus td. This is in the form of sine x by x, therefore it is the sinc function, sinc of pi, that sinc of omega c of t minus td will be your h of t, impulse response. When we draw this impulse response, we'll observe that h of t is the shifted version of the sinc function by the how many number of units is td units. Therefore, the graph of this particular sinc function will appear like this. Take the point of td, at t is equal to td will have the maximum value, then slowly it will forms the sinc function like this. This is our h of t with the maximum value at here is omega c by pi. This is the maximum value which is having in the value at t is equal to td. Once we know this h of t impulse response of an ideal low pass filter, that is, we know that h of t of a low pass filter, ideal low pass filter, Then take the input as x of t and the output as y of t. Now the step response is, that's y of t is equal to simply generally we know that x of t convolution with h of t. But for the step response, x of t will be nothing but u of t, unit step signal. Therefore, our y of t will be equal to u of t convolution with the h of t. Then it is equal to minus infinity to infinity. Take the convolution form, that is h of tau, u of t minus tau, and d tau. What is h of tau? As h of t will be equal to omega c by pi into sinc of omega c of t minus tau. Therefore, the h of tau will be written as omega c by pi sinc of omega c of tau minus td, u of t minus tau, d tau. Therefore, the limits of this particular one will be given as it is to be from minus infinity to t. It's from the minus infinity to t. As we have the u of t minus tau, whereas the u of t will have the limits 0 to infinity, then u of tau will have the limits from 0 to infinity, u of minus tau will be from minus infinity to 0. Therefore, u of t minus tau means add the t units. That's why minus infinity to t units. That will be the limits of this u of t. U of t is equal to minus infinity to t. Then omega c of e by pi sinc function will be written as sine form. Omega c of tau minus td by omega c of tau minus td d tau. Keep it as this one as our first equation. Laterwards we will use that particular equation. Then when we simplify this entire thing, let consider this omega c of tau minus td as a one particular variable of x. Therefore, dx will be equal to omega c of d tau, as dt will be a constant. When we put x is equal to, that is, when we put the tau is equal to minus infinity, x is also minus infinity. When we put tau is equal to t, then x is equal to omega c of t minus t, like this. Here, when we put in place of tau t, then x is equal to omega c of t minus t. Therefore, our y of t will be given as, the integration will change us to minus infinity to omega c of t minus td, then omega c by pi. This will be written as sine of, this will be the x, omega c of tau minus td will be the x, denominator also x, and the d tau will be the given as dx by omega c. This particular omega c, this omega c will get cancelled, and keep this 1 by pi as outside. Integral of minus infinity to omega c of t minus td sine of x by x dx. This entire thing is nothing but our sine integral function. First we should study about the sine integral function. Laterwards we'll get the expression for our y of t. We have got that y of t has been as, which is equal to minus infinity to t omega c by pi s sine of x by x dx. Therefore, this integration will be as, this omega c is also cancelled, then 1 by pi from minus infinity to omega c of t minus td, omega c of t minus td, sine integral of sine of x by x dx, which is equal to, this entire thing is a sine integral function, that is sine integral function si of x is equal to integral of sine x by x dx. When we know the properties of sine integral function si of x, the first one as sine integral of x is an odd function, odd signal, that is si of minus x is equal to minus si of x, and the second one si of 0 is always 0. The third one si of infinity, it will be pi by 2, and si of minus infinity, which is equal to minus pi by 2. Therefore, when we draw the graph of this sine integral function si of x, it will appear like this, which is having a minus pi by 2 value, and the pi by 2 value. Like this, with respect to the x. Now come to this particular y of t. When we simplify that one, y of t will be given as 1 by pi si of x with the limits from minus infinity to omega c of t minus td. Therefore, substitute the limits 1 by pi of si of omega c of t minus td minus si of minus infinity. Then 1 by pi of, what is si of omega c of t minus td is as it is, minus pi by 2. Si of minus infinity is minus pi by 2. That is equal to 1 by pi si of omega c of t minus td plus pi by 2. Now if we take the omega c values, then we'll get the minimum and maximum values of the y of t. That is, when we take the omega c as infinity, when we substitute here infinity, y of t is equal to 1 by pi si of infinity plus pi by 2. As si of infinity is pi by 2, therefore pi by 2 plus pi by 2, it is pi gets cancelled, which will be equal to 1. When the omega c is equal to minus infinity, y of t is equal to 1 by pi si of minus infinity plus pi by 2. Whereas this one is minus pi by 2 plus pi by 2, which leads to y of t as 0. Therefore, the minimum value of the y of t is 0. This is minimum value. The maximum value of y of t as 1. Therefore, the graph of this one will appear like this. That's y of t, which is being delayed by the td units. That's why it will be center at td. The center will be at td and the minimum value is at 0. Therefore, the graph will appear like this. At td, we'll have the graph like this. We'll have the graph of the y of t will be like this. Its minimum value as 0 and maximum value will be 1. Therefore, at the maximum we'll have this 1. And it is being delayed by the td units. That's why it is centered at td. Therefore, it will be centered at td with the minimum value as 0 and the maximum value as 1. And it appears similar to that of this sine integral function. Therefore, for calculating the rise time of the equation, we'll observe that output is being shifted from 0 to 1, that is 0 percentage this one, this is 100 percentage. Therefore the time taken for the output to travel from 0 percentage to 100 percentage will be nothing but our rise time TR. How to calculate this particular rise time is, draw a one particular tangent which touches our TD with the maximum value as y of t is equal to 1 line and the y of t is equal to 0 line. The tangent should be from the y of t is equal to 0 to y of t is equal to 1, and which has to touch at the t is equal to TD point. Therefore, this particular rise time will be given as 1 by TR is equal to dy of t by dt at t is equal to TD. What is this dy of t by dt is from our first equation, that's from 1, that is omega c by pi sine of omega c of t minus TD by omega c of t minus TD at t is equal to TD, this one. Therefore, the expression for this particular one as, if we take the t is equal to TD here, that is, which will be given as, that's omega c by pi, it appears as the limit of t minus TD tends to 0 sine of omega c of t minus TD by omega c of t minus TD. Therefore, it is in the form of sine x by x tends to 0. Therefore, its value will be 1. Therefore, we'll get the omega c by pi, which is nothing but the left side as 1 by TR. Therefore, the TR into omega c will be equal to pi. That's TR, and TR means the rise time, into this omega c is cutoff frequency, which is equal to pi constant. Therefore, the rise time into, specifically for the low pass filter, this cutoff frequency will be written as, this cutoff frequency as will be nothing but our bandwidth. That's omega c is itself our bandwidth. Therefore, the rise time TR into bandwidth is a constant, is a particular constant. That is the relation between the rise time and the bandwidth, which is always a constant equal to pi. We have taken it as a low pass filter expression. Therefore, TR into omega c, which is equal to pi. Here the TR into bandwidth, which is equal to a constant. This is the basic relationship between the rise time and the bandwidth. Thank you.